So today we will talk about HDFS components. Basically, we are going to see the roles and the responsibilities of the various processes which we have seen, right? Which we know now the Hadoop is managed by five processes, namely name node, secondary name node, data node. This is for the HDFS, and then resource manager and the node manager, and this is for yarn. Yarn stands for yet another resource negotiator, and we will see we will see the roles and the responsibilities of all these five processes. Along with uh, we'll see how does the writing happens on HDFS. When we say writing, we mean that how what happens behind the scenes when you perform HDFS DFS minus put command. So whenever you run this command, what happens behind the scenes? It's nothing but how does the writing happens on the HDFS. Similarly, we will also see how does the reading happens on the HDFS, which means that what happens behind the scenes when we run the command HDFS DFS minus get. So you have a get operation and you have a put operation. So get operation is for reading the file from the HDFS or reading the data from the HDFS, and putting is putting the file on the HDFS or writing a file on the HDFS. So we'll see that how we'll see these operations in detail. So let's see that process is running on Hadoop. Now by this time, you are very much comfortable when I say master machine, then what all processes it runs on that machine. And also when we say slave machine, then what all processes run on that machine. So since the above machine is a master machine, so it will have three processes. So here name node, secondary name node, um, job tracker. This is Hadoop 1.x. Instead of job tracker in the Hadoop 2.x, it will be resource manager. And you have a data node and task tracker. So data node and task tracker on the slave machines. Again, task trackers in the Hadoop 1.x instead of, and in Hadoop 2.x instead of task tracker, it is node manager. Let me just quickly change this here as well, so that I resource manager here.
उधर उधर मैं लिख रहा हूँ
Node manager.
तो मैं निकाल
नहीं यूज करता है ना
हाँ
तो रख देना है
ठीक है चलो बंद कर दो शिवित ये फैन थोड़ा एक बढ़ाना एक बढ़ा पूरी ग्रीन लाइट अरे ऐसे यार हाँ उसको बंद कर हाँ चलो थैंक यू
So that's what in the master machine you have name node, secondly name node resource manager, and in the slave machines you have data node and node. Now let us see that how HDFS is designed. Now HDFS is designed. So this is just an overview of the slides, that overview of how HDFS is designed. So HDFS is designed for storing very large files. Okay, we'll understand in the next slide that what do we mean by this statement when we make HDFS is designed for storing very large files. Okay, we'll talk about that in the next slide. HDFS is designed for scaling in terms of storage. And what kind of scaling we are talking about here in HDFS? We are talking about horizontal scaling. And what do you mean by horizontal scaling? Horizontal scaling means that adding more machines in parallel. Yep. It is designed for mitigating hardware failure. And when we say Hadoop, in Hadoop, failure is common rather than exception, or in other words, you can say uh, failure is an accepted behavior rather than exceptional behavior. So if failures are happening, that means it takes the failures as a part of your system. So it does not throw away exception or does not shut down the machines when the failures are occurring. And most of the time, the biggest, or you can say that the biggest failures are nothing but the machine failure. What happens when the machine goes down? Your process goes down, your data node goes down. But Hadoop is designed to mitigate the hardware failure, which means that even though machines are going down, it will make sure the data is not lost, and the processes or the tasks which are running on that machine will be automatically be will be automatically be rescheduled on some other machine. So, and this is because of the presence of replicas. So it mitigates the hardware failure by the replica placement mechanism, or replica placement mechanism, or I would say replication feature. Because of replication feature, it mitigates the hardware failure. It is designed for batch mode processing. We'll understand in a little while what do you mean batch mode processing. It is designed for write once and read many times. Now, understand that Hadoop, when it was designed, it was never designed for real-time writes. It was never designed for real-time writes or the updates. When you say write once, it basically means that you are going to upload your large amount of data, probably terabytes of data, one shot, and then you read that data many times for different analysis purpose. Okay, just 1 minute, guys. So that was our explaining. So write once and read many times. It means that you are going to write your data, big data, terabyte of data one time, and then you read it several times for different analysis purpose. So it means that put your big data once and then read this data multiple times for different analysis purpose, right? Also, I would like to emphasize the fact here that Hadoop was not designed for a real-time updates. It was never designed for real-time updates. Okay, it is built on commodity hardware. Again, you need to understand that when you say build on commodity hardwares, but as an administrator, you should understand the commodity word itself starts from 32 GB RAM, 8 CPUs. So that's your commodity definition. Your laptop which you use probably have 4 GB, 8 GB, or 16 GB, they don't even come under the category of a commodity hardware. So when you say Hadoop is designed for commodity hardware, it basically you should understand that minimum machine criteria which falls under commodity hardware is a 32 GB RAM and 8 CPU, 8 cores, and something like that, right? But nevertheless, no one's we have seen that we can run our Hadoop on a machine with a 4 GB RAM and everything as a and we have seen that, right? We can run on a machine on a lower configuration as well, right? So that's
So,
possible.
so I have a question. When you're saying 8 CPU, are they physical 8 CPUs or
Yeah, yeah, 8 cores.
4 plus 8 cores? Actually, 8 cores.
Yeah. Now,
Okay. Okay.
yeah, it is compatible across several OS. You can run on any of the OS. The reason is Hadoop requires a JVM or a virtual machine or a Java, and it is written in Java, and Java is your platform independent language, right? And it's a highly fault tolerant system. And we have seen in the previous section that it achieves the fault tolerance with respect to two: one with respect to the data, another with respect to the job. Again, I would like to re-emphasize here, when you say fault tolerance with respect to the job, it means that even if the machines are going down, the job execution continues. And Hadoop is a fault tolerant with respect to the data. It means that even if the machines are going down, the data is not lost, and it achieves because of the replicas, right? So job execution continues even the machines are going down, because the tasks which are failing, they will be rescheduled on some other machine. So, and that's possible because of the presence of replicas. So that's what, in the nutshell, we have seen that how the HDFS is designed. Let us see a few things, like first, why Hadoop? What do we mean by this statement that HDFS is designed for storing very large files? What do we mean by batch mode? Those stuff we are going to see in detail. Now, when we say,
So,
yeah,
can you go to the previous slide? Actually, as far as I'm not sure. You have mentioned that it's compatible with Windows. Is it compatible with Windows also,
it does. It is
or
compatible with the Windows, but you need a Cygwin interface to start and stop the processes on Windows. It's not recommended to run on Windows, the Apache Hadoop, but yes,
okay?
you can run your Hadoop cluster on Windows as well. Yeah, it requires a
Oh,
Cygwin interface. Cygwin for the running the command
okay.
line things. So understand Hadoop is
So,
being designed for your Linux kernel, not for the Windows kernel. To make your commands to understand the Linux kernel, you require an interface. That interface is known as a Cygwin, using which you will be running the Linux-like commands on the Windows.
but is it possible to store
Very
the
well
data
possible.
on Windows
It's
also?
very well possible.
Very well possible. Okay.
Yeah.
Thanks so much.
Yeah.
Yep.
Okay, HDFS is designed for storing very large files. So as soon as we say it is designed for storing very large files, the question comes to our mind that is it not suitable for storing small files? Now we have two kinds of files now which we have introduced now, large files and the small files. Now that's why we need to understand what do we mean by a small file and the large file with respect to Hadoop. Okay, before going further, you need to understand in literature, you need to understand the one simple fact that HDFS is efficient for storing small number of larger files rather than large number of smaller files, right? It's efficient for storing larger files than the smaller files. In a nutshell, or in a simple words, it is efficient. HDFS is efficient for storing larger files than the smaller files. Now let us see that. Now assuming you have a one file of 1 MB. Now, now if I have 1,000 such files, then it's 1,000 MB. But this big, so you are talking about big data, in fact. But this big data is made up of lot of smaller files. So you have taken one file, and then you have a lot of smaller files, and in entirety you are talking about big data. So this is also a big data, but this big data is made up of large number of smaller files. So they are larger in numbers but smaller in size. So these are larger in numbers, but smaller in size. Hadoop says that I'm not efficient for storing such scenarios, for storing files like this. If you want to store these many files, it's better if you can make a one single file of 1,000 MB, or you make two files of 500 MB, or you make four files of a 250 MB each. So these are small number of larger files. So this situation is smaller in numbers but larger in size. So this situation is smaller in number but larger in size. So what is large file and small files? So small files are those files where the size of the file is very much less than the block size, and the default block size being, let's say, 128 MB in Hortonworks. So larger files are those files where the size of the file is very much bigger than your block size. So that's why Hadoop says that Hadoop is not efficient for storing smaller files. Hadoop is efficient for storing larger files. So that's why the statement that Hadoop is efficient for storing efficient for storing small number of larger files. These are smaller in numbers, larger in size. So it is efficient for storing small number of larger files rather than large number of smaller files. The reason there are two direct impacts which we are gonna see one by one. The two direct impacts of using the lot of smaller files is, you will see very shortly that this is the first thing. It increases the name nodes metadata information. The increases the name nodes metadata, and you will see that what will happen if the name nodes metadata, which is stored in RAM, which is stored in name nodes JVM heap space, which is stored in name nodes JVM heap space. So if it increases the name nodes heap space drastically, then it will not have enough RAM to sustain, and the process might go down. And if the process goes down, then the HDFS will be inaccessible. We're gonna see in detail later. And also HDFS, okay, if you use a lot of smaller files, that means you have to spawn lot of, if you are processing, with respect to processing, you have to spawn lot of tasks. And if you want to spawn lot of tasks, then scheduling would be a problem. The reason why I'm saying scheduling would be a problem, because you might not have enough resources to schedule those many tasks. Scheduling would be a problem, and if scheduling is a problem, then that means to say that you are going to affect the performance. So performance will be affected. Okay, that's what I have seen here. Larger files means the size of the file is greater than the block size. And just now explain, Hadoop is efficient for storing larger files, remember that, and not efficient for storing smaller files. It's always, so it is advisable to store a bigger file than the smaller files, but most of the time you might not get a file which is very much greater than this block size. Let's say if you talk about Tomcat logs, then the size of those logs is very small. It will be few MBs, right? So what is advisable is, if you are working with the smaller files, then what you should do is to merge those smaller files to make a bigger file, and then push on to Hadoop, and then push to HDFS. That is recommended. So if you are working with smaller files, then before you push to HDFS, merge those smaller files, create a bigger file, and then push to HDFS. So it's always so HDFS is efficient for storing um, larger files, and it is designed for scaling in terms of storage. Of course, we have seen. I hope I have seen you this exercise wherein I brought up one node, and then without disrupting the services, we have brought up second node, and we have added our second node to the existing Hadoop cluster. So it is designed in scaling in terms of storage. Again, understand what kind of scaling we are talking about here. We are talking about horizontal scaling. Horizontal scaling means adding more machines in parallel. So this is your let's say 3-node Hadoop cluster. You would like to add another machine, and so you so without disturbing the services, you can add other machine. I mean to say that you can add a new machine without disrupting the existing services. Mitigating hardware failure, HDFS. Remember that HDFS is machine agnostic. Machine agnostic means that it is anything which is a machine agnostic means it's independent of machine failures. So we say HDFS is machine agnostic, and or in other words, we say HDFS is independent of machine failures, because if machine fails, nothing will happen. Only thing, the data will be lost. So when the machine fails, what happens? Data is lost and the task is lost. But since you keep the replicas in some other machine, so a data is not lost, and the task can also be recovered. So this is just an explanation that you have 3 blocks. You have, let's say you have one B1, this is also a replica B1, this is also a replica B1, and a machine goes down, but still your data is intact on some other machine, on the other two machines, so the data is really not lost. We'll understand this bit in very soon. Whatever I explained here, name nodes, very sorry, name node try to recover the lost blocks from the failed machine and bring back the replication factor to normal level. Or this statement is little, I would say, confusing. Let me just change this. I will just write it here that the major responsibility of the name node is to keep the replication factor to a normal level. We'll talk about that in a where we'll talk about this particular bit very soon. Batch mode processing. What do we mean by batch mode processing? So before you understand the batch mode processing, let me again take you to the example of your Google Drive. So let's say this is your Google Drive and you put your file onto your Google Drive. Let's say the file name is sample, and behind the scenes that file gets broken and replicated and distributed across your machine like your HDFS. Okay, so this is not seen to you only see only single file on HDFS, right? Now, what is a batch mode? Batch mode means that even though the file is broken into multiple blocks, but you don't have the flexibility to access and analyze the individual blocks. What do I mean? That if I want to read one line of this file, I have to download the entire file to my local box, and then I should be able to read that single file. What does it means with respect to with respect to Hadoop when we say it's a batch mode processing? It basically means that irrespective of how many blocks the file has been broken into, you have to process all the blocks of data at any given point of time. You cannot say that I want to process only the first few blocks or I want to process only the last few blocks. You don't have that flexibility. So batch mode basically means irrespective of how many blocks the file has been broken into, you don't have the flexibility to access individual blocks. At any given point of time, if you are processing this data, you have to process all the blocks of data. And please understand that Hadoop was never designed to read. Hadoop was never designed to read single data, single entry, or something like that. Hadoop was designed to process terabytes, petabytes of data. Okay. Okay. To make it more simpler or to make it more clear, what exactly this batch mode processing means. For example, you have put your file, sample file, and this sample file has a terabyte, is of terabyte, assuming the block size is 64 MB. So when you break this file, it will nearly have a 16,000 blocks. Now you want to read the first line of the sample file, or let's say you just wanted to process one small amount of data. So when you say it's a batch mode, so even though you require only the first line, you have to process all the 16,000 blocks. Okay, so that is known as batch mode. So that's why it was not used for real-time updates and everything, real-time read and writes. It was never designed for real-time reads and writes. Hadoop. It's a batch mode. It's designed for crunching or processing large amount of data. Now this is a high-level overview of your um, Hadoop. So here I always make this bifurcation. This is your cluster, and this cluster is in US, let's say, and this is your client. This guy can be probably from India. So if you see this operations here, if I am doing a file operation, now you guys are comfortable when I am talking about file operation. Only the name node, data node will come into picture, and this would the first step. Just a minute. So this is your first step. You contact the name node, and then you do an operation on the data nodes. So OP is nothing but your operation, and any operation which you do on the file system, it boils down to only two operations. Either that operation will be a read operation, or that operation will be a write operation. Any operation you talk about, that operation behind the scenes, it's only can you do read or a write. In a one way or the other, it will be either a read operation or a write operation. So we'll see what happens. How does the reading and writing happens in the HDFS? And if you talk about this flow, it's basically you're submitting a job, and here you can think of resource manager in Hadoop 2.x. So you contact your resource manager. The reason is these two guys are master processes, and master process has two properties: Spark and this SPOF. Spark is nothing but your single point of contact, and SPOF is your single point of failure. Now we do understand the meaning of a single point of contact, single point of failure. So name node,
So,
yeah.
when we are trying to do any operation or on HDFS, the client will always go to the name node. It won't go to the resource manager for reading and writing the data from HDFS. It won't go to resource manager.
Have you seen my last class video?
Yeah,
So I
actually
hope,
here you showed that the resource manager also. No, sorry, I got confused because of that.
can you please see this? What's
Yeah.
happening here? I hope I have clearly shown here diagram. It says submitting a job.
Mhm.
This is a file operations. When doing the file operations, resource manager will never come into picture. In the last class video, I have explicitly explained you that you can very well shut down the resource manager when you are doing the file operations, so that it is outside it is beyond the, I mean, say, it should not confuse you that resource manager plays any role when you're doing the file operations. Please go to the video, it will be clarified. I do remember that I was explaining you this concept.
Yeah.
Now, name node is your single point of a contact to the outside world. Single point of a contact basically means whether whomsoever is performing the operation, they should know where the name node is running. And it is specified by the property fs.default name, or it's also fs.default fs. If you open that, it will show you something like this: hdfs colon slash slash your host name colon 54310. What does it mean? It means that name node is running on a machine whose host name is whatever you have given here, and is whatever you have given here, and is listening to it, and is listening on port 54310. When I'm saying client, anyone from the outsider, any machine, or it could be anyone, anything, anyone, if they would like to do operations on the HDFS, they should know the address of the name node. Basically, they should know this address. Okay, and then only they will be able to communicate or do the operations on the HDFS. Without knowing that address, without knowing this address of the name node, they will not be able to do that. And since if you want to find out that which file I should look out for this property, then you should see the prefix of the property, and the prefix does not start with the DFS, nor it starts with the MapRed or the MapReduce, nor it starts with the yarn. So it will be under core-site.xml file. I already have explained this in my previous slides, previous modules, so you should be in comfortable position to find out, to understand that which property belongs to which file. Okay, now what is the important, what does it do, the name node? The name node stores the metadata. Metadata means that data about data. A data which tells about the data. For example, if I say Manoj Bhattacharya. Now, if you see, so this Manoj, if I take out this Manoj, and if I want to know what is this, who's this guy, whether which part of India he belongs to. So if you see this title and or surname or this metadata, then you can very well tell that this particular guy, this guy belongs to Kolkata. Are they right? So he's a Bengali. He belongs to Calcutta. So so this guy is a metadata. So this particular data is your metadata. Something is happening very weird with my machine today. So what does the name node stores as a metadata? So I hope that point is clear. What do we metadata? So metadata with respect to the Hadoop is given a file, how many blocks it has been broken into, and which all data nodes are hosting those blocks. That is a metadata for the with respect to the name node. Also, list of files and their directories. It basically means that on my HDFS, how many files and directories I have. Right, so that is your metadata information, which the name node stores. Okay, so to be more concise, it's something like this. More concise information with respect to this, given a file comedies, you have seen that in the last class when we were performing the operations, that comedies file we have, it was around 1.7 MB, and we have put this file with a 1 MB block size, so it was broken two blocks, B1 B2, and B1 was hosted with machine, let's say I'm just giving you 0 1, and B2 is hosted with machine, let's say 0 1 and 2, let me 0 1 and 3 for the explanation purpose. I have taken 4 machines. So this is information is stored with the name node. So given a file, how many blocks it has been broken into, and which all data nodes are hosting these blocks, and this metadata is kept in the RAM. Why anything needs to be kept in the RAM or the memory? I would say JVM memory of name node. Why it has to be kept? Because anything which is the memory, then it becomes very fast, or it is easier to access them, or it is easier to access them quickly. And since this information is very critical, or this information will be accessed very frequently, so it makes sense to keep this information in the JVM memory, or I would say that to make it simpler, RAM. Okay, so for faster access, this metadata is kept in RAM. But the problem with the RAM is that it is a volatile memory. And what do we mean by volatile memory? It means that if if the name node process goes down for some reason, then this entire metadata information will be lost. But understand this information of given a file, how many blocks has been broken into, it's very critical. You cannot afford to lose this information. That's why this metadata is also stored persistently on the local file system. And that image, that file is known as fs image file, which is, and this fs image file is your persistent state of metadata. My cluster is not running, or I would have shown you where to find out this file. Or if your cluster is running, you can go to this property df. You can go, you check what is the value of this property, dfs.namenode.name.dir, and go in whatever the value you have given, go inside that particular directory, and you will see that there are two files over there. One is fs image, another is edits file. You'll find two files over there, fs image and edits. We'll talk about edits file, but right now the fs image file is clear to you. That fs image file is nothing but your file system image. It's a persistent state of your metadata. Okay, so this information, if you see here, so name node stores this information given a file, how many blocks it has been broken into, and let's say if this machine 0, this is machine 1, 2, 3, 4, 5. So it will store this information that BLK001 is stored with machine 0, machine 3, machine 4. Likewise for all the blocks. Now, if you keep one file, it will have one entry in the metadata. One file. If you put another file, you will have one more entry in the metadata for that file. If you keep on putting lot of smaller files, then what will happen? The name node's RAM will be quickly exhausted, or JVM memory will be quickly exhausted. And if it is exhausted, then the name node process will come down. And if the name node process comes down, you know what will happen. The HDFS will be inaccessible, right? Because name node is single point of a failure. And that is the reason that HDFS is not efficient for smaller file. Okay. Now we came up to a very important conclusion here, that regarding the scalability limit of Hadoop. So scalability limit of Hadoop is determined by name node's RAM. How much of a memory you have given to the name node, that will determine the scalability limit of Hadoop, because it is going to determine how much of a metadata you can store. Okay, so that's with respect to the name. Now name node is down. You understand that now that HDFS is inaccessible.
So,
Yeah.
I have one question on this metadata.
Mhm.
So actually, like when the name node starts, does it put the entire FS image, or it is part of the FS image which goes into the RAM?
You should answer this question.
Actually, in my opinion, I think whatever the previous state of the HDFS is, it will load the entire metadata at the start.
Of course, it has to enter all the entire metadata information. What is the point in loading the partial FS image? Because information will be partial, right? And you will, and at any given point of time, the entire information has to be present. You cannot say that which information you. How will you say that which information I will not load? How and which information I will load? How do you determine the criticality of an information? Information is information, and entire information and all the information is critical. So you have to load the entire metadata at any entire metadata, and this entire metadata has to be loaded on the memory at any given point of time. So you will never ever say that I will load this, I will unload this, and all. No, the entire metadata information has to be in the memory throughout the lifetime of Hadoop, whenever still the name node is running. Is that clear?
Okay. Yeah, makes sense. Thanks.
Yeah. If name node is down, HDFS is inaccessible, and that's why we say it's a single point of a failure. So I will say it's a SPOF, single point of a failure. Any operation which you do on the HDFS, it is recorded by the name node. Now, in a distributed environment, um, chance of losing the information is very high. Very sorry. What I'm trying to say that chance of losing, the probability of losing the information is very high. Why it is very high? The process can go down, machine can go down, right? And there can be other reasons as well because of which the machine, because of which the information can be lost. But your main intention is how do you prevent? How do you prevent this thing, that this is this losing of information and all? So what do you do here? You first persist it somehow. So before, so how do you do this? The simple thing is, before you update the memory, you first write, you first persist or write that information. That's how you make sure that information is not lost. So that's why I'm trying. So this is what I'm trying to make you understand, that any operation on the HDFS, any operation which changes the state of HDFS, it is recorded by the name node, and it is done in the edits file. Okay, so which changes the state of HDFS, any operation which changes the state of the HDFS. Examples like put operation, of course it will change the state of HDFS. MKDR operation, change mode operation, change ownership operation, etc. Those are the operation which changes the state of the HDFS. Operations which does not change the state of HDFS, like ls, get, what else, cat, etc. So these operations does not changes the state of the HDFS, so they are not recorded. But these operations changes the state of the HDFS, so they are recorded in the edits file. Yeah. Now coming back, how does the name node handles the data node failures? How does name node handles the failures? Or in other words, how does name node will come to know about data node failures? How does it comes to know? So in the introduction module, I have told you any master process has three properties: Spock, SPOF, and ego. Any master process. So name node is your master process, data node is your slave process. Name node has an ego problem. He is being a master. He is an ego problem. He will never ever contact the data nodes. Data nodes are the slave process, so they have to send the heartbeat signal periodically to the name node. They have to send the heartbeat signals periodically to the name node. Periodically could be the periodicity could be 1 second per second. They have to send the heartbeat signal, and okay, if the name node does not receive the heartbeat signal for a default time of 10 minutes. So that is configurable again, but the default time of 10 minutes, if it does not receive the heartbeat signal, then it assumes the data node is down, and it will do something to bring back the replication factor to normal, because if the data node is down, then that block is lost, because we know that replicas are physically stored by the data node machines. So this is important here, that how does the name node will come to know that the data node has gone down. So these guys, the data node processes, they need to send the heartbeat signal to the name node periodically. Per second, it's ideally, I think it's configured to as a per second. So the data nodes have to send the heartbeat signal periodically to the name node. And if in case the name node does not receive the heartbeat signal for the default time of 10 minutes, then it assumes the data node is down. Okay, now that's the responsibility of your name node. If talk about data node, so data node stores the actual data. We have seen that replicas are physically stored with the data node machines. And you know where to find out this. You have to look out for this property, dfs dot data node dot data dot dir, and the value, if you go inside that directory, you will find out the blocks there, that you will find out those blocks. along with the Along with the data file, you will also see a .meta file. Along with the block, you will always see a meta file for verifying the integrity of data. This is your CRC file. CRC stands for cyclic redundancy check file, for verifying the integrity of the data. So basically, if the block gets corrupted, how do you find it out? How do you find? So this meta file will help in finding whether the block is corrupted or not. Okay. Now, what does it do? So data node, as I have just explained, the data node will send the heartbeat signal to the name node, and as a part of the heartbeat signal, it sends the block report. And what is block report? Block report is how many blocks and how many blocks I have, and what are the IDs. So number of blocks and their block ID and their IDs. So that's it sends as a part of the heartbeat signal. Every time it does not need to send the entire block information. It could be an incremental block information also is fine, right? And secondly, it also sends the storage capacity. Storage capacity basically means that how much is used and how much is left. How much is used and how much is left, that is the storage capacity. And number of data transfers happening. So we'll talk about this in a little while, that what do we mean by this. And this guy, or I mean to say, this data node will be considered down if it is not able to send the heartbeat signal for the default time of 10 minutes. So what the main responsibility of the data node is to send the block reports and storage capacity and the data transfers happening, and this information will be used by the data node, will be used by the name node to find out if a block of data can be allocated to if a block of data can be allocated to that data node. So this information will be used by name node to figure out whether a block of data can be assigned to or not. It should not happen, because understand that name nodes take the decision that where to place the block, right? And it should not happen that if you have 1,000 data nodes, only the few data nodes are getting all the blocks of data. The rest of the machines are not getting the data at all. So name node takes the decision where to place the block and make sure that the blocks are uniformly distributed across all the machines. And you do have the flexibility to balance the blocks. So there is a script HDFS-balancer.sh. So you can manually balance those blocks as well. I'm not sure whether it's the same script, but there is one script which is present using which you can balance the blocks. And please understand, now name node never contacts the data nodes directly. And what does it do? That if the name node has some work, then it will give the instruction to the data node. So you have understood that a name node is a master process, never ever contact the data node directly. Data node has to send the heartbeat signal periodically to the name node. If name node has some work with this data node, then it will instruct, please understand, it will instruct the data node to do the activity. What kind of instruction it generally gives? So instructions like replicate the blocks, in case of under replication, remove the local block replica in case of over replication. Under replication, we'll talk about this very soon. Over replication, we'll talk about this very soon. So what does it say? The data node receives the following instructions from the name node as a part of the heartbeat signal. Replicate the blocks in case of under replication. Remove the local block replica in case of over replication. We'll talk about this term very soon. Just now I have explained you that name node's major responsibility is to keep the replication factor of any file to a normal level. What I mean by this, for example, you have a file 1 which is put onto the HDFS with a replication factor of 3. So for this file, the normal replication factor is 3. There's another file 2 and the replication factor is set to 5. For this file 2, the replication factor is 5. Normal replication factor is 5. There's another file 3, the replication factor is 10. So for this file 3, the normal replication factor is 10. And what I mean by the name node makes sure the replication factor is always kept to normal level, it means that for this file 1, the normal it will try to keep all the replicas intact, that all the 3 replicas intact for each block. For file 2, it will try to keep all the 5 blocks intact, all the 5 replicas intact for every block. For this file 3, the 10 replicas per block, it will try to keep it alive. Even if the machines are going down, that's his major responsibility. So let us see that how does it do it. So this is a normal scenario wherein I am putting a file gets broken behind the scenes, replicated, distributed across several machines, but still you are not sure that who is going to break the file. And let us not be under any assumption that framework or client or whomsoever. Let us just say that the file gets broken, replicated and distributed across several machines. And we know that replicas are physically distributed across several machines. Replicas are physically stored by the data node machines. Now here is a normal scenario wherein you have a file, let's say a sample file has been broken into only one block, and that block has been with machine 0, machine 1, machine 2, and this is the name node's metadata which it's stored. Right now all the machines are up and running, so it's a normal replication factor. Now, machine can go down for a number of reasons. Maybe network, maybe machine has some problem, or some of the other reason that machine has gone down. So this particular data node will not be able to send the heartbeat signal to the name node. After 10 minutes, the name node will come to know that this machine has gone down. So normal is 3, normal is 3, normal is 3, but the current alive number of replica is 2. So this is a case of under replication factor. Now at this point of time, what does it do? The name node, so you know that, right? It will send the heartbeat signal, and the name node came to know that the machine has gone down and B1 is under replicated. So it will instruct one of the machines which has that B1. So instruct this B1 to copy this block of data to some other machine, let's say 3. So it will instruct this data node to copy this B1 block of data to some other machine. Okay. Please understand here I have written the block will remain under replicated if no other slave machine is available. If this machine is not available, then the block will remain under replicated, because you understand that no two same replicas will ever reside on the same machine. So that's why the statement says the block will remain under replicated if no other slave machines are available. So, but for the explanation purpose, I have taken another slave machine. So this will copy this data to slave 3, and now your all the 3 replicas are intact, and the replication factor is back to normal. So that's your, from under replication it has become a normal. But this machine, this was a network glitch. Network glitch, because of which this was not able to send the heartbeat signal. And let us assume the name node is, and let us now assume that it has, now the network is proper, and it's this data node starts sending the heartbeat signal. Now here the normal is 3, but the current number of replica is 4, which is a case of your over replication factor. In this case, the name node will instruct one of the data nodes to remove the local block replica and bring back the replication factor to normal. So this is how under replication scenario and over replication scenarios are handled. So here number of data transfers happening. This was the scenario wherein when the name node was asking this data node to copy this B1 to the other machine. So this was number of data transfers happening. So this information is also sent to the name node as a part of the heartbeat signal when the data node is sending. Okay, so that's basically your data node responsibilities. Now coming back to your secondary name node. The first thing about the secondary name node is the name itself is a misleading, which brings the notion of like it's a backup kind of a name node. That means if the name node goes down, then it acts as a backup, right? So the very first thing you should understand, it is not a backup or a standby name node, which means that if name node is down, it is down. Secondary name node will not act as a name node, backup name node, whatever. Okay, the only responsibility of the secondary name node is to merge the edits file into fs image file periodically, so as to keep the edits file in the sizable limit. So as to keep the edits file in sizable limit, so that next restart doesn't take too much of a time. So that is the only responsibility of the secondary name node, that it is the responsibility of the secondary name node is to merge the edits file into fs image file, so as to keep the edits file size into a sizable limit, so that the next result does not take too much of a time. If the secondary name node is not running for a longer amount of time, then the only problem would be Hadoop will next restart will Hadoop, and in the next restart, Hadoop will be in the safe mode for longer amount of time. I'm not sure whether you are aware of safe mode or not. So let us say safe mode is your read-only mode. Read-only mode. When you say read-only mode, which means that you are not permitted to do any operation. When the Hadoop is in safe mode, you are not permitted to do any operation. Now, when does it goes into the safe mode? It goes into the safe mode automatically during startup. It goes in a safe mode automatically during startup and then comes out automatically. Now, why does it goes into the safe mode? Remember that just by running the command start-all.sh or whatever script you are using to start the processes does not mean that all the Hadoop processes are up and running, right? Though it starts the process does not mean that Hadoop is ready and can present himself for the operations. Hadoop is not a single click process. That's what I mean. It's not a single click process. It means that as soon as you start the process does not mean that you are ready. It's ready to do an operation. You are talking about bringing of 1,000 node Hadoop cluster, and it has to start the processes. Name node that you have just now seen, the data node sends the heartbeat signal. Then the name node has to maintain the metadata. Name has to bring up the metadata information, everything in the memory. So during this, all these processes, housekeeping activities, when it is reading the FS image file, bringing up the metadata and all, Hadoop goes into the safe mode for a small amount of time. And when it so for that small amount of time, when it is in the safe mode, you are not permitted to do any operation. Which means that if the Hadoop is in the safe mode, you cannot do file operation. When the Hadoop is in safe mode, you cannot submit any kind of a jobs. Once out of the safe mode, then only you are permitted to do. Then only you are permitted to do any operations. Sometimes you can automatically enter into the safe mode also manually also by running this command. An administrator can enter into the safe mode. Hadoop DFS admin minus safe mode enter. So this using this command you will enter the safe mode, and the same command Hadoop, there is no space. DFS admin minus safe mode leave, you can come out of the safe mode. So the safe mode is basically read only mode, and the only reason when the safe mode, the only problem if what will happen if the secondary name node is not running. If the secondary name node is not running, then there is as such no problem with respect to your functioning of HDFS and the yarn. There is no problem. If secondary name node is not running, then only problem would be the size of the reads file will become very big, and next restart will take too much of a time. And what is meant by next restart will take too much of a time? It means that Hadoop will be in the safe mode for larger amount of time. Okay, so that is the purpose of the secondary name node. The secondary name node, what does it do? It just periodically merges the edits file into FS image file. And since we are talking about reading, merging, and everything, so any kind of a reading, merging, or writing operation, it's a CPU intensive operation, and it's advisable in a bigger cluster to run on a different machine other than the name node.
So,
Yeah.
I have one question. Assuming that today I start the name node, at that time my FS image would be say FS image 1. So when we do operation on Hadoop, which does the change of the state, it will record all those things into the edit logs. So does so I mean secondary node is required to put the data which goes into the edit logs back into the FS image file, and would it create a new FS image file which has the previous FS image plus the current edit logs?
Okay, let us understand this scenario. What happens here? Um, I got your question, so let me see that whether your question gets answered or not in the next 5 slides. So you have initial setup. Let's say you have done a Hadoop setup. You have FS image file. You have a edits file. And for the explanation purpose, I have taken 0 bytes here. But understand that by default, any empty file will have a 4 bytes. Now, you did a start all.sh. So when you do a start all.sh, what does it do? The very first step during a restart, it tries to read the previous state. It tries to read the previous HDFS state by the FS image file. Whatever is there in the previous HDFS state, it will try to read the FS image file. And file is empty, so nothing will happen. First step. Then it will try to see if there is anything in the reads file. During startup, secondary name mode is not coming into any picture. It's just operation. Secondary name mode is not. I'm not talking about the role. It is what's happening during the startup. So step two, name node will see if there is anything in the reads file. So it will start applying the modification from the edits file. And the step three, once the modification is done, once it has read the edits file, so there is no use of edits file anything. So what does it do? It will edit the MP file. It will empty the edits file and merge with the FS image file. So become a one big file, FS image file. Now, right now, and during the startup, it does not. I mean, during the startup, everything is very fast because there is nothing in the FS image and the edits file. And during this operation, when it is doing it is reading the FS image file, reading the edits file, emptying the edits file, and again merging with the FS image file. Basically, it's very confusing, right? During this operation, when it has reading the FS image file for the previous HDFS stored, then merging, then reading the edits file, merging into the FS image file after applying the modification. During this operation, it is in safe mode. Now, once the Hadoop is in the safe mode, you start doing operation. Already in the previous section, I have explained you that whatever operation you do, it is first recorded before it is updated in the memory. So whatever operation you do, if it changes the state of the HDFS, it is recorded in the edits file. And the edits file size will increase. Please understand, FS image file is not increased. Edits file. And after some time, edits file size will start increasing, and then you have stopped. Then you have stopped your cluster at this state where your size of the FS image is 0 and the edits file is 10 MB. You have stopped at this state. And then again you have started your cluster. It will restore the previous HDFS state by reading FS image file. Nothing is there, it would be a faster operation. Then it will start applying the modification from the edits file. Something is there because 10 MB file is there. So it will apply the modification, and once the modification is done, it will empty the edits file and push and merge with the FS image file. Since there are some entries in the edits file, so it will remain in the safe mode for a little longer amount of time. Now, this three steps happens during the startup only. If you see that, now FS image file will be more or less 10 MB, but it will not, I mean to say, it will not be that much. Yeah. Now, if you have observed, if you then what will happen if your cluster is running for a longer amount of, for a longer time duration, that is 6 months, 1 year, and if secondary name node or nothing is running, then you will see that the edit file size can grow very big over a period of time, and the next restart can take too much of a time with this scenario. So the only thing what does the secondary name node does, it will periodically it will come every 24 hours. That's the default time. Periodically it will come and merges the edits file with the FS image file. That's it. If it is running on some other machine, then it will take the copy of the edits and the FS image file, merge it, and then pushes back to your name node. So if your name node is running on this machine, so if it will take up FS image file, edits file from this machine, SNN will pull this FS image edits file, it will merge it and then send it back. The new FS image file. Does it answer your question?
Yes, so very much. Thanks for the very great explanation. Thanks so much.
Thank you.
Uh,
Okay.
so, so actually, I have one more question here. See, over the period of time, is it does HDFS keep only one copy of FS image? Because if
Can
it
keep multiple
runs say for
copies of FS
1
image
year,
file. Previously, it used to give one copy, but now it has appended some serial numbers. It can give multiple FS image. How does it matter? It has to just read the any file you start as FS image. No.
okay, okay, yeah, yeah, makes sense.
Yeah.
Yeah.
Now let us talk about
Thanks.
how does the reading and writing happens on the HDFS. So that completes the roles and the responsibilities of your name node, data node, and secondary name node. The secondary name node responsibility, you should be clear that it is different. Even if you don't run it, there will be no effect on the functionality of your HDFS and the on the yarn or MapReduce jobs. Name node, secondary name node responsibility is just to merge the edits file into FS image file periodically, so as to keep the edits file size into a sizable limit, so that the next restart does not take too much of a time. Okay, the only problem will be if the secondary name mode is not running, Hadoop will be in the safe mode for a longer amount of time. Safe mode is known as a read-only mode, wherein you are not permitted to do any operations. You cannot do any file operations. You cannot submit any jobs. Okay, and Hadoop goes in the safe mode during the restarting of the machines automatically for some amount of time. Automatically, it comes out of also comes out also. Administrator can manually turn on the safe mode for doing some kind of a maintenance activity, and then they have to come out manually also. So the command which I have shared. Now coming back to the how does the writing and the reading happens on the HDFS?
So,
Yeah,
Uh, sorry to interrupt you. Actually, I have one more question on SNN. Actually, till date, I was under the impression that SNN is used as a backup of the name node. Like in case if a name node fails, the data like FS image and edit logs would be present in the SNN. So that's not the case, right?
yeah,
So it is just to push the edit logs into FS image.
yeah,
It's not a backup of NN, right?
yes, yes.
Okay. Okay.
Now let us see
Yeah.
that when you
Maybe
run,
my
yeah, Hadoop fs minus put your source file, and then you give the destination on the HDFS. What happens? So writing a file. So you let's say you have issued this command Hadoop fs minus put sample. At the first step, it will contact the name node. The name node will give him the metadata information, and then he will write onto the data nodes, and the data node will send the acknowledgement, and the name node will update the metadata just at a high level again, not gone to details. First step, second step, third step, this is your fourth step, and this is the fifth step, that is updating the metadata, saying that the file has been broken into one block B1, and the B1 is hosted by 0, 1, and 2 machine. Assuming this is data node 0, data node 1, data node 2. Now let us see in detail what happens. And it's a very big process. This is a client. We have a name node, and let's say 3 data nodes. Okay. Now you issue a command saying that I want to run this Hadoop FS minus put sample. That's the file name is A, and you want to keep on HDFS by A1. So the very first thing, what does it do? What you do? You contact the name node, because name node is single point of a contact. Name node gives back him that it creates a block ID. So first operation is this. The second thing, what does the name node does? Name node creates a block ID. It creates a block ID, let's say B1, and it will ask 3 data nodes, let's say 0, 1, and 2. It asks 3 data nodes to host those block, and this to host this block, and this entire information goes to your client. Now the client has the information that he has to write. He has to write on a B1 block of data, and on this machine 0, 1, and 2. Please understand that this file, that whatever the file he is writing, it has not moved to the cluster at all. It is still with the client. Now what does that do? Now client starts reading the file. So client has opened the file, and it has started reading the file. Now as a step 1, 2, 3, this is the third step. It has received the metadata. At the fourth step, what does it do? It writes a 64 KB of data and pushes this data to the first data node. It pushes this 64 small amount of data, which is configurable by this property DFS dot client hyphen packet dot size, which is your 64 KB. So this small amount of data is pushes to the first data node. This data node will push this data to second data node, and this small amount of data pushes to the third data node. This is known as pushing the data to the pipeline. Pushing the data through pipeline. Now this process of pushing the data, of this process of pushing the 64 KB of data, this process of reading the 64 KB data and pushing this to the data node will continue till a block of data is completed. And once the block of data is completed, then these data nodes will anyway send the heartbeat signal to the name node. Sixth step. Then at the seventh step, the name node will update the metadata saying that the file A1 has been broken into one block, and that block is hosted with 0, 1, and 2. So one block has been created for this file. If you are writing another block of data, then again all the steps has to be performed from the step 1 to step 6. So if he has to write, let's say, because you are writing a terabyte of data and it has to write 16,000 blocks. So for every block, it has to contact the name node. Name node will give him a block ID and the list of the data nodes. He will start reading the 64 KB of data and put that data into first data node. That first data node will push to the second data node. The second data node will push to the third data node. That is known as pushing the data through pipeline, and this process will continue till the block is completed. Once the blocks are completed, they will send the heartbeat signal to. They will send this information to the name node via heartbeat signal. The name node will then update them metadata saying metadata, right? So this will happen. Is this clear?
So it means one block is filled by the client in chunks of 64 kilobyte. It's not that the client will push size equivalent to one block. Correct? If I understood correctly.
Yes. So the two important things which you should understand here is who breaks the file. The first thing, it is not the framework who breaks the file, it is a client. Client is nothing but is the guy who from the client is the one who from where you are performing the operation, right? Is breaking the file. That's important. That you should not be under the impression that it's a framework who is breaking the file. It is the client who is writing the file. He breaks the file. Okay. The second thing is the blocks are written independently.
Som,
Yeah.
Som, I have a doubt. Yeah, you said like it is client which is breaking the file, and client means from where we are performing the operation. So normally, assume that I'm just putting a file to HDFS. I'm issuing a put command. Okay. So in that case, who is the client? The user?
You tell me, no?
Yeah, for me, it'll be the user.
From which machine you are performing the operation. So whatever the user or whatever user you are using. That's why if you remember, I was
Okay.
always use this concept of client is in India, my cluster is in US. Did I
Okay.
make this bifurcation when I am doing this? This is in US, this is in
Yes.
India, and you are doing the operation from here. So this
Okay.
machine, this
Okay.
user is going to break the file.
Okay.
Yeah. Okay. So
Okay.
blocks are
Yeah,
written.
got it.
Yeah. So blocks are written independently, which means that. So explain this bit. Blocks are written independently. So one block of data is does not know that other block does exist. So blocks are written independently. So what does it means? That for example, let me say, um, so what does it mean? If blocks are written independently, that the blocks are unaware that they belong to the same file. It and the name nodes using the metadata, it knows which block belongs to which file, right? Now let us say that I have this scenario. um, Client 1 has issued this command, Hadoop fs minus put some file a by a1, and this client and this command has completed two blocks of data, and the third block is in writing, is in process of completion. It's not yet completed. And the client 2, what does it do? It says Hadoop fs minus cat a1, the same file. So what will happen? Will it be able to read the data, or will it get an exception that saying that this data is not complete and all? So since you should understand the blocks of data are written independently, so Hadoop fs minus cat a, this client will be able to read the data till the two blocks, till the completed blocks, I would say. Will be able to read the data till the completed blocks. So in this case, it will be able to read the data till two blocks of data. Okay, because the blocks of data are written independently. So nothing. So I want to say. It will be able to read the two blocks. The third block, which is not completely written, it will not be anyways be updated in the metadata. So he will not be able to see. That's one thing. Okay. The second, let's say, client has written 4 blocks, and while writing the 5th block, client dies. So my question is, what will happen the rest of 4 blocks? So what do you think? What will happen to the rest of the 4 blocks? Will it be rolled back because it was not completely written, or will it stay because they are independently written? What will happen? So the 4 blocks which has been written, they will be present in the 4th block. I mean to say, nothing will happen to the 4th block. There will be no rollback. The 4 blocks which has already been written will be present on the HDFS. Will not be removed, because because with respect to the HDFS perspective, the blocks are written means it is written, because it works only on blocks. But with respect to the client perspective, he knows that he got died in between, so the file is not completely written, right? So it's the responsibility of the client that if he wants to write, if he be the responsible client to remove that file and again rewrite it. It's not the responsibility of the uh, framework. Now, reading a file from the HDFS, it's a straightforward process. So in this reading, so let us go back. So in the reading part, now again I will make this bifurcation that you are in India and the cluster is in US. The name node, so you have a sample file broken into B1, B2. B1 is stored with machine 0, 1 and 2. B2 is stored with machine 0, 1 and 2. Let's say this is 0, 1 and 2. And here you have a B1, B2, B1, B2, B1, B2. Now, client sends a request, Hadoop fs minus get the sample file, and let's say sample underscore local. So what will happen? The first request goes to your name node. Name node sees the request that he wants to read the sample file. So the entire metadata information is sent back to the client. So second step, entire metadata information is sent back to the client. Now at this point, client knows that he has to read two blocks of data from those two different machines. So what does it do? It can read this B1 block of data from this machine, and parallelly it can read the B2 block of data on this machine. Then it can merge B1 and B2, and then sample underscore local. It can create the sample underscore local file itself. So the question which you need, the concept which you need to understand is who merges the block and create the file. It is not the framework that will merge all the blocks and give it to the client. It is the client who will read all the blocks of data on its own side, and it will merge the file. Is that clear?
Yes, sir.
Yeah. Now the other thing which you need to understand here is you read this concept which is known as short circuit reading. Please read the concept of a short circuit reading for improving the read performance. To give you an idea, whenever the client, and you have a data node here, and the data node stores the blocks. So whenever the client requests that to request the data node on the port 50010, whenever the client will request the data node that I want to read the B1 block of data, what does this data node does? Data node will read the block on client's behalf and gives over the port 50010 on which the data node is listening. So it gives the entire block of data up to the 50010 and then it goes to the client. This is what happens. Short circuit reading, it means that client can directly read B1 by bypassing data node. So the client can directly read the B1 block of data without doing any of this, bypassing the data node and the 50010 port to improve the read performance. So this is known as a short circuit. So you're short circuiting, right? So this is a short circuit reading. For improving the read performance, generally you do a short circuit. Now my third thing is, how does the corruption is handled in the blocks? How does corruption of blocks is handled in HDFS? For example, you have this scenario where the name node and you have three data nodes. Data node 0, data node 1, data node 2. And you have this information. Sample file has been broken into two blocks, B1 and B2. The name node is stored has this information as a part of the metadata. B1 is stored with 0, 1 and 2. B2 is stored with 0, 1 and 2. So you have a B1, B2 here, B1, B2 here, B1, B2 here. And now client says Hadoop FS minus get. Client is in India, and he issues the command Hadoop FS minus get sample file to sample underscore local, whatever local file. So the first step, it goes to the name node. That's your first step, and the name node will send the entire metadata information back to the client. So client has now sample file broken on B1, B2, B1, 0, 1 and 2, B2, 0, 1 and 2. So now when he's reading the B1, so the B1 gets corrupted. B1 is corrupted because let's say the checksum file does not match. So what does the client will do? Client will, as soon as the B1 is corrupted, so what does the client will do? So this guy will inform name node that B1 on machine D and 0 is corrupted. And what does the client will do? Client will read B1 from other machines because you have a replica, right? So client will read B1 from other machines. Okay, now that is with respect to the client, but now as soon as client receives this information that as soon as the name node receives this information, the client that the B1 block of data is corrupted, then the name node will instruct this data node 0 to remove block B1. And as soon as the block B1 is removed, this will be under replicated. And just now we have learned that if it's under replicated scenario, then the name node will instruct some other data nodes to replicate the blocks on the machine. So let's say we have third machine, so it will be replicated on the same machine, and it will bring back the replication factor to normal level. So this is how the corruption of the blocks is handled in HDFS.
So,
Yep.
see, in this example, it is the client which informed name node that there's a corruption of a block. So, like, if is there any other way in which name node can know that a particular block has gone corrupt?
No.
If there is no interaction by the client.
No, never. So to answer this question logically, you need to answer this question before you can think of answering this question. You need to answer this question. Okay, and then your answer will be in front of you. You are running a shop. And as a shopkeeper, how will you come to know that your rice which you have kept for selling is not good? Can you answer this question?
Yes. Yeah, I mean, if a client comes, he says the quality is not good, then only I will come to know. Yes.
So you will not cook your rice daily in the shop, right? Before opening your shop, you will not cook that rice daily, no? It's the one who uses that rice and then they will give you the feedback. Then only you will come to know that your rice is not good. Similarly, why the name node will do this activity of finding it out, because you are talking about a 100 node Hadoop cluster, millions of blocks, an unnecessary operation that it is going to scan the blocks and find out whether it is corrupted or not. But there is a concept of a block scanner, but I'm not sure what is a block scanner does that. Whether it will scan this for the corruption or not, but the block scanner runs on the data node machines. But I hope you got the idea that name node will not do this activity.
So, it's just about thought with what you explained. Uh, does it mean, assuming that for a file, block 1 gets with a replication factor of 3, all the 3 blocks, say B1, 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 on 3 replication gets corrupted. So, is there a possibility?
Possibilities are there. Of course, there is a possibility, but the chances of getting all the three
Less.
blocks is very less.
Yes.
Yeah,
Yeah.
it's very less. But
Understood.
yeah, but it's there. Possibilities are there, but chances are very less.
Yes.
So this is how the reading and writing happens on the HDFS, along with the what we have studied today, roles and the responsibilities of name node, data node, and the secondary name node. Regarding the yarn processes like resource management, node manager, I will take you in the coming slide. I'll take you in the next classes, not today. So that's all for today, guys. So in the next module, we'll talk about sizing, which we have already done it, commissioning, but we'll also talk about decommissioning and then quotas. And when we come to the resource manager roles and responsibilities, I will talk about map reduce and everything in that section. So yeah. So we'll a couple of so for the next few days we'll be doing hands-on exercises like commissioning, decommissioning, assigning quotas, name node HA, yarn HA, capacity scheduler, upgradation, alerts, a lot of other interesting stuff which we'll want to do in the next couple of modules. Okay, so that's all for today. So let's meet tomorrow. Thank you.